All right, guys, welcome. Today we're going to go ahead and talk about graphing a function when we are given, here we are given the f prime function, so I'll label that. And I want to go ahead and sketch the graph of f. So I am given f prime, I want f, and I'll label that in red or something of what I want. Okay, so the first thing that we're going to do is go ahead and find out like what did they give us? Well, keep in mind this right here is a f prime function. So anything that is above, like all of this from -8, right, all the way to 2, all of that is positive. So when a function, I'm sorry, when the derivative, when the slope is positive, that means my function is increasing, just like that. And if it helps us, we can use the fun chart. Hide this little setting. There you go. The fun chart. And it tells me that this right here, some little quick reminders about this. So right here, we can see that when the derivative, right, the derivative is positive, that means my original function f is increasing. Okay, so let's go ahead and use that information. All of this right here is positive, so therefore it is increasing. All the way, right, all of this right here, all of this right here is positive. So all the way from -8 to 2, the function is increasing. Now from 2 to 6, and I can go ahead and highlight that to make it a little bit easier to see. All of this is below the x-axis. My derivative, my f prime, is negative. So that means that f prime is negative. So therefore the function, the original function, is decreasing. Now, last but not least, the function goes back on top, goes positive, so therefore it is increasing. So that was not too bad. The next part that we're going to try to do is find out what the concavity is. So for that, we will look at the slopes. So we go ahead and erase this real quick to find out what the slopes are doing. Are they increasing? Are they decreasing? So something that I picked up, and it's a little bit easier to see, is to go ahead and look at where it starts, right? Remember, we start from the left and from here. So breaking it up into sections. So we can see that from here to here, the slope is decreasing. Okay, and we can see that by the tangent lines. So when the slope is decreasing, that means we have concavity down. Okay, the next part from -5 all the way to 2, right? From -5 all the way to 2, we have that the slope is looking upwards, right? We look at all these tangent lines and they are increasing, so we have concavity up. Now, whenever concavity changes, that means at -5, we have a point of inflection. Now we can go ahead and go from -2, right? From -2 to -1, right here. We can see that the graph is still going upwards. It is still increasing, so we have more concavity up. Okay, from here to here, from -1 to 2. So from here to here, we can see that the slope is decreasing. So this is going to be concavity down. And once again, this concavity changed. So what does that tell us about -1? When concavity changes, we have a point of inflection. And right here, we have the 2 to the 4. So from here to here, we can see that the slope is still decreasing. So therefore, it is still concavity down. And here we have that the slope is increasing from -4 to 6. We can see that the tangent lines are going to be increasing. So that means concavity up. And once again, concavity changed. So therefore, we have a point of inflection. And last but not least, from 6 to 8, we can see that it's still increasing. So we have more concavity up like a cup. Okay. Something that I forgot to mention, and I just noticed it right now, is this vertical tangent. Vertical tangents are very important. Any sort of discontinuity on our graph, this right here is going to be a cusp, because we cannot find the derivative of vertical tangent. Okay, if you think about your rise over run, you're rising infinity in 0 horizontal movement. Okay, now something else that we can also see, and I totally forgot to say it, is this right here. Like when our graph changes from an increasing to a decreasing, that means we have some sort of maximum. some local max. So I'm going to label that at 2, we have a max. And here at 6, you can see that it's decreasing and then increasing right here. So whenever we have decreasing, increasing, we have a minimum. Okay. Now, we can go ahead and label these right here before we go ahead and start. So something that helped me out is labeling these a little bit better, as in these vertical lines. I know in class the whiteboard is not as nice as I used to do it, but if we go ahead and take a little bit of time and stretching out these points, they should be okay. So it says, hey, it starts when x is -8, my height is -2 for my function f. So that's the first point I'm going to put. And then based on what they told me, it says it's increasing. So I'm just going to go ahead and increase. Now, it doesn't matter how high or low you go because we don't know the exact height. So I'm just going to go ahead and put it to cross at 6 just to make it my inflection point at 6. And then it continues to increase here. Now, I know someone was writing in pen, but notice we still need to go back and talk about concavity. So I'm going to go something like that to 2. I'm sorry, for -5. Yeah, up to -5, there's a cusp. So -5. I'm sorry, not -5. What? -2. So somewhere here, there's going to be a cusp. Okay. So I'm going to go back and now use my concavity. So from -8, right? From -8 to -5, we have that it's concavity down. So I'm going to go ahead and try to make this some sort of parabola like that. It's increasing and concave down. So something like that. Then at -5, like right at here, there's a point of inflection. And that's because my concavity changed. So here, my concavity should be upwards like this. So it should remind you of like some sort of cubic function, like the ballerina, like that. So that's what this should look like. So let's see if I can try to erase the green here a little bit. Make it a little nicer. Whoops, totally messed up. But that's okay. Makes it a little bit cleaner. And this is concave up all the way to 2. And hopefully it makes it a little bit easier to see that this cusp is going to appear. So from -2, right, from right here, from -2 to my -1, it's also concave upwards. So this one is going to be concave upwards. And you can see that that little spike is happening. Exaggerate it a little bit. Okay. And that -1, we have a point of inflection. So I'm going to make a big dot right there. There's a point of inflection. And that's because concavity is going to change. So once again, it's going to go ahead and change. And notice it's going to stay concave up from -1 to 4. And at 2, we're going to have a maximum. So I'm going to go ahead and jump a little. And at 2, I'm going to go ahead and put a dot right here. This is going to be my max. And I'm going to be concave up just like that. Okay. All the way to 4 is where I'm going to have my other point of inflection. So it doesn't really matter as long as you have some sort of height. And then eventually we'll find out how high these actual points will go. But right now it's just a sketch. Okay. So we have something like this. We have some concave downwards, like a frown, right? From -1 to -4 to 4, +4. Okay. Now at 4, we have another point of inflection because concavity changes. So right here. Okay. So I'm going to go ahead and see, and now from -6, I'm sorry, 4 to -6, it's going to be concave up like a cup. And be careful, we have a minimum at 6. So I'm going to go ahead and stretch this out. It doesn't matter how high you go. So right here, this is going to be a minimum. And my last part is to draw this concave upwards. And then just make sure you stop somewhere at 8. That's where it ends. Okay, so hopefully this made it a little bit better, a little bit more clear. I know the concavity kind of made it a little bit trickier, but hopefully it's not too bad now. Now in class, one of the questions was, hey, how come we don't know where it crosses the x-axis when we're going from Let me label this. This is f. We're going from f prime to f. Well, majority of this is because of this right here. If I was to give you, I don't know, 3x squared, okay, plus some number, I don't know, let's say 7. And if I was to derive that, that would give me 6x, right? Now, what would you say is the derivative? Whoops. What would you say is the derivative of 3x squared plus, I don't know, 17, or 3x squared minus 500? What is the derivative of those graphs? They're also 6x, right? But because of those constants here, like that plus c, whatever number you have here, we derive it, it becomes 0. So that's why we don't know where the height goes. So that's where I put this -6. I'm sorry, at this -5. I put it right here, but just because I thought it would be nice. That determines, guys, that max. Some of you guys will draw the max all the way over here. Some of you guys will draw the max right over here. Some of you guys might draw your min all the way over here, or maybe here. That all depends on what this was. Now, will we eventually learn how to find that? Yes, we will. But currently, right now, we're just trying to sketch the graph. Okay, so I use both the fun chart. I know eventually after doing these quite a while, some of us might not need this, but use it. It break down the intervals, and it should be okay. And I forgot to label it. It's cusp of the sharp corner. Okay, so hopefully this helped and made it a little bit more clear, but I'll try to explain it in class a little bit better. But hopefully this helped. Okay, I'll see you guys in class, and thank you.